Okay, this is question number 1 in assignment 2. W. Bill and Martha open a saving account for their granddaughter. She's only 1 year old. They make annual deposits, so I'm gonna highlight the words that they're making deposits, not just one. 2,000 into this account each year on her birthday. And the interest is 5% compounded annual. Question A. How much money will they have the account when she turns 18? We're trying, since they want to see how much money she's going to have when she turns 18, then they're asking for future value. And since they're making deposits, so multiple entries, we need to use future value annuity. So you go S equals C, 1 plus R to the T minus 1 over R. R is always the rate in the question over M. The rate in the question is 5%. And since they tell you it's annual compounding, when annual, M is 1. So R would be 0.05. T is always whatever your M is, which is 1, times time in the question. This is 1 times and 18 because it's 18 years. So we put everything together. C would be the amount that they're investing, and that's 2,000. 1 plus the R, which is the 0.5, exponent 18, minus 1.05. So it's just a calculator. You go 2,000 times brackets, another bracket, 1 plus the 0.5, exponent 18, minus 1 over the 0.5. And this will give you 56,264 and about 76935. And put the answer in a sentence. So something like she's going to have 56,264 and when she turns 18. That's A. B. They're traveling the year she turns 12 and unable to make the 2,000 deposit. How much will she have in her account? So everything is okay. They made all the different payments. They missed one payment. The one payment they missed, the $2,000 when she was 18. So we need to know, okay, that $2,000 when she was 12 that they missed, what's the contribution of that $2,000 to the 56,000? So we need to find the future value for only one payment. Anytime you do a future value for a single payment, not for deposits like this one, we use the formula P1 plus RT. The payment they missed is 2,000. It's the same interest. And they missed it when she was 12. So this 2,000 would have been invested from 12 to 18, like over 6 years. So you put that in the account, in the calculator again. That tells you that the contribution of this 2,000 is actually 2,680,19,1281. So that means she has in her investment the 56 minus this. So the 56,264 minus the 268 191281. So, final answer, she would have in her investment 53,584,57807. That's the answer for the first question, question number 1. Question 2. Question 2. Ivana Birch just turned 20. She received a gift of $50,000 from her rich aunt. She likes to plan ahead and would like to retire when she's 55. So she's 20 now. She's going to retire when she's 55, and at 20 she received $50,000 from her aunt. She thinks that she'll need to have about $2 million saved by the time in order to maintain the lavish lifestyle. So when she's 55, she thinks that she needs to have $2 million in order to keep her life the way she was living. She plans to make a deposit at the end of each month until she's 50 into an account she'll open with her aunt. So she's going to invest the $50,000 plus she's going to put some money into her account till she's 50. After 50, she plans to stop making deposit and let the money grow until it becomes $2 million. When she turns 55, assume she earns 6% monthly, how much she can deposit into her account to achieve the objective. So, now, the account is earning 6% monthly. Now, let's think of the story. So she's 20. She's going to make deposits into her account, and all these deposits that she's going to make each month, end of the month, so monthly deposits into account from age 20 to age 50, whatever she was able to accumulate, she's going to leave, and it will grow to become $2 million, and then she can achieve the goal. So we have two things happening. She's 20, she's doing some action till she's 50, she's leaving the money till she's 55 to become $2 million. So the first thing we need to do is, we need to know what is that 50,000, because she's putting this 50,000. What is that 50,000 or this 2 million here? So I'm going to bring this 2 million back to age 50, because we need to know how much she's able to accumulate here in order for this to become. So we're bringing it back, and it's only going to bring it back as a lump sum. So we're going to use P equals future 1 plus R to the negative 2. So again, R would be whatever the rate is over M. They tell you it's 6%, you divide it by 12, it's 0.05. And T is always M times time. So M, again, is 12, and we're looking at 5 years old. That's 60. So present value equals, the future is the 2 million. 1 plus R, so 1 plus 0.05 to the negative 60. So 2 million, 1005 to the negative 60. This amount is 1,482,744,392. This is the amount here. So now we know that she needs to accumulate this amount. If she leaves this amount in the account, will grow to become 2 million over 5 years. Now that's her target. That's her target in the future. Okay. So what's going to happen now? To reach this target, she has two sources of investment. The 50,000 invested to get the target, plus certain monthly deposits to get the target. So two of them to get to the target. Well, first thing we need to do is, okay, let's figure out what this 50, the contribution of 50,000 to the target. Remember, the target is the 1,482,744,392. So this 50,000 is invested one time. So you go future value equals present value 1 plus RT. So 50,000 still at the same interest, but T is different. It's still monthly, but it would be from age 20 to age 50, so that would be over 30 years. That's 360. So you put 50,000, 1.005 to the exponent 360. So it's 301,128,7606. So that means that she doesn't need to get this amount. Her target is this minus the 301,128,7606. So the deposit that she needs to make is to accumulate this amount of money. So she needs to be able to accumulate about 1,181,000. And since she's making multiple deposits, we're going to use the annuity feature. So I'm going to use, to figure out the deposits, the S equals C 1 plus R T minus 1 over R. Where the future is the target of 1181,615,631. C we don't know. Interest still 005. This number still 360 of 005. So we do this in two steps. So 1005 exponent 360 minus 1 over 005. This number here is 1,004,515,042. So C, and that's what we're solving for, is this over 1,004,515,042. 1,181,615,631 over the amount of money that she needs to make is 1,176,304,566. And again, put the answer in a sentence. So she needs to make monthly deposits of about 1,176. In addition to the 50,000 over 30 years, she'll accumulate 1,482,000. She can leave that for 5 years, and that becomes 2 million. That's the answer for question number 2. That's the end of part 1. Part 2, I'll do question 3 and 4.